So here we go. This is better. In the example of the East Madagascar current, we see something that we will see again with the Agulhas current. Okay, western boundary current. Okay, so there are the swiftest currents on Earth, speeds above a meter per second. And so what happens here with the East Madagascar current? So it's confined to the shelf break, runs around the shelf break, and as it reaches the southern coast of Madagascar, it actually creates something we call a retroflexion area. So it moves away from the coast, swings around, turns around, and then flows to the east, and at the same time also creates eddies, which propagate and move further east. We call this eddy shedding. And here are some trajectories of GPS drifters on the left map. So what you can see here is you can see the African southeastern coastline of Africa, and you can see Madagascar and some drifters. And you can see drifters that actually move along. It looks almost like a gyre type of circulation. It's anti-clockwise there, but you can also see the features of eddies. Yeah, so there's some eddy features, and then as you move through this area, okay, of a fairly dynamic mesoscale eddies, okay, you actually come to the Agulhas region. So this is the East Madagascar current. Okay, let's see how it looks like. Not yet. Okay, so just one more addition. This is just one example of one of these eddies produced by the East Madagascar. Okay, it shows you a vertical transect, okay, cutting through an eddy. This is the temperature field, and you can see near the surface is a 20 °C spot near the surface, so it has a higher temperature near the surface, and between down to 1,000 meters, you can actually see upward bending isopycnal. Okay, so what this eddy does, it actually produces an upwelling of isopycnals. Okay, this is an upwelling eddy over quite a depth range. Okay? So now what's important about these type of eddies? First of all, the upwelling itself indeed can, if it's intensive enough, can lift nutrient-enriched waters into the euphotic zones in some of these eddies. But also what these eddies do is they actually move horizontally across the oceans like waves. Okay, this feature can actually move along the ocean. And that's the fascinating aspect of these eddies. And that's why there are of such an interest to scientists, these eddies, because of their productivity, and also because of their, they also can have they can also change the productivity of a large region, because these eddies can actually move around. Okay.